So this video is in continuation to electrochemistry, and this video part 2 is in continuation to that. So in this video we will focus on spontaneous redox reactions. So spontaneous redox reaction. For example, like if I'm having one container in this way, I'm having a beaker here, and here there is a copper sulfate solution. So here there is a copper sulfate solution. So I'm writing in this way, copper sulfate aqueous solution, which will be blue colored. So blue colored, okay. So and you dip a zinc rod into it. So you dip a zinc rod into it. This is zinc rod. So zinc rod made up of zinc atom. So you are having two things here. One is the zinc rod, and that means you have zinc atom here, okay. And then because you are having copper sulfate, so you are having copper plus 2 ions, and you have sulfate ions, okay. So now with the passage of time, what you will observe, that what is happening here that the rod, so here what will happen, that this zinc rod, the weight of this zinc rod will decrease. So the weight of zinc rod will decrease, okay. And what will happen, this the bluish color of this copper sulfate solution, that will go on decreasing. So what will happen with the passage of time, there will be a few observations. The first observation is that weight of zinc rod decreases, okay. So the weight decreases. Second will be blue color. So the blue color of copper sulfate solution, so blue color will disappear. So blue color disappears. And the third observation will be that there will be here down, you will find that here reddish brown precipitates will be there. Reddish brown precipitates are observed. Also, temperature also increases. So these are like the observation which are observed when you dip, like you put a zinc rod in a copper sulfate solution. So with the passage of time, these things are happening. Now why this is happening, what is taking place, like you are simply putting the zinc rod. So what is happening here, so if you remember the reactivity series, so at that time also you know that. So let me explain these points one by one. So the explanation for this reaction, the reaction which is taking place here. So the first thing is that zinc is more reactive. It is more reactive than copper. So it has a stronger tendency to get oxidized. That means that zinc is having a weaker pull for the electron. So what will happen? Zinc atom that will tend to lose electrons as it has weaker pull for electrons. So the first thing, this is happening. So what is happening? Zinc is more reactive, and zinc what happened, because it is having a weaker pull for electrons, so zinc tend to lose its electron. Now the second point is, now what is happening to copper? Now here you are having copper plus 2 ions. You don't have copper metal or copper atom here, okay? So copper plus 2 ions are there, and copper plus 2 ions, they will be having a strong affinity for electrons. So because they will be having strong affinity for electrons, so it will try to pull the electrons toward itself. So now what is happening in actual? Zinc is giving its electron, or we can say losing electrons, and copper plus 2 is gaining electrons. And now because zinc is giving its electrons, so it is oxidized in this whole process. It is oxidized because losing electron is which process? Oxidation. So zinc is oxidized in this whole process, and copper plus 2 is reduced in this whole process. So zinc is giving or losing electron, and it is oxidized. Copper plus 2 is gaining electron, and it is reduced. How we will write here? Now the first thing, like how do we know that zinc is going to be oxidized, like and copper plus 2 is going to be get reduced? So this is because we have a chart called electrode potential, or we can say series, potential series, or we can say that it is standard reduction potential series, which we will do afterwards. So standard reduction potential series is there, and looking at this series we come to know like which of the element will be oxidized and which will be reduced, because in this series the elements are arranged in this way that the element which is having strong affinity for electrons is placed above. Okay, so here what you will find that copper plus 2 will be above in this series. So copper plus 2 will be above and zinc will be below. So copper plus 2 has a strong affinity for electron, so it will gain electron, and zinc is having less affinity for electron, so the tendency will be that zinc atom will lose electron. Okay, so now how to represent these the oxidation reaction and reduction reaction? Now here the first will be oxidation half reaction. How will you write it? So zinc giving its, so zinc forming zinc plus 2 ions, and it is giving 2 electron, and this is half oxidation reaction. Okay, and then copper plus 2 will be gaining these 2 electron, and it will form solid copper atom, which will be deposited at the bottom of the container as reddish brown PPT. So at the bottom you are getting this thing. Okay, and so they will be forming copper atom. So this is half reduction reaction. And how do we represent it? So it will be zinc plus copper plus 2 forming copper plus zinc plus 2, and here energy is also released because this is spontaneous reaction, and we can feel this energy in the form of heat, because we are not using any wire here like anything for electron to move, or and we are not using bulb here so that we can see that the bulb glows here because of the production of the electrical energy. So here right now, the energy we will observe that the beaker we are using here, that will become hot. So that means the energy is released here. And this type of reaction where oxidation and reduction, so this in this type where oxidation reaction and reduction reaction are taking place, these are taking place in the same vessel, we call it as direct redox reaction. So direct this is direct redox reaction. And the reaction, okay, so next we will study galvanic cell, and you will find there that at that time we will have different vessels where oxidation and reduction taking place, like oxidation taking place in one vessel and the reduction in another. So here you will be having different vessel where oxidation and reduction take place, and we call it as indirect redox reaction. So direct redox reaction and indirect redox reaction.